Hello my friends and welcome back to another exciting episode of Mr. Johnson's Math Class. For today's episode we are looking at similar figures and scale factor. By the end of this episode you will be able to determine if two figures are similar and you will find missing dimensions in similar figures. So the little example that I got here for you just to kind of get us going. Let's say that you visit New York City and you go to the Statue of Liberty and you buy a souvenir model of the Statue of Liberty. Those would be similar and they probably follow a scale factor. So kind of think of like a model or if you're looking at a map or something like that. Let's get some key terms down here real quick. Similar just means that they have the same shape. Now I'm not an artist but I'm gonna do my best here. Let's say that we had this triangle and pretend just for a second that we copied and pasted it and we made like a little smaller triangle. So they were the same shape and the corresponding angles. So say that angle and that angle had the same measure and those two had the same measure and then these two, squeeze that in there, those had the same measure. So those would be similar, similar triangles or similar figures. So they have the same shape. We'll talk in just a minute what corresponding sides means. We've talked in class and in previous episodes what proportional is, and corresponding angles. We'll talk in just a second what corresponding angles are. So essentially the corresponding parts are proportional or equal, and they are similar. So really just think of it as the only difference really is their size. All right, so let's talk about corresponding sides and corresponding angles under the heading of corresponding parts. I'm going to change my pen here. So we have triangle ABC and triangle DEF. So let's talk about corresponding sides. They are in the same relative position and they are proportional to one another. So here we have let's take side AB. So let's say that you had side AB and it corresponds to side DE. And then, I'm gonna change, just get a different color here. And then you had side BC, which would be proportional to EF. Alright, and then for our third side, you have side AC is proportional or corresponds with side DF. So those are our corresponding sides and they're in the relatively the same position. What that means is, so side AB, which is this side here, is in the same position as DE and they're going to be proportional. So they're going to follow a scale factor because they're corresponding sides. So now let's talk about corresponding angles. Alright, and we have, so let's say that we had angle A. So the measure of angle A, so when you see this symbol, let me make a little side note here. So this, like, you read that as saying the measure of angle A. And sometimes we'll write it like that. You may see it written kind of like a measure. Some people do it that way. But essentially they mean the same thing. So measure of angle A. So measure of angle A is equal to the measure of angle D. They are corresponding because they're in the same position, have the same angle measure. Let's see, I'm going to do measure of angle B. And the measure of angle B is 86 degrees, and if you look at the other triangle, you see that the measure of angle E is equal to measure of angle B. And off to them, let's scoot over to the side, and we've got the measure, so measure of angle C equals the measure of angle F. So that's how you would list corresponding parts. That's your corresponding sides. This shows that they are proportional to one another. And again, they're proportional. So they follow a scale factor. They're not the same size. So really what we've done up here is write a ratio comparing the smaller triangle to the larger triangle, with all of the smaller triangle parts on the top, or in the numerator, I should say, and then all of the larger triangle parts in the denominator. And then you have the corresponding angles, and those are equal, so we can write them as equal using an equal sign.